Red-eared slider turtles are originally native to the United States, yet they have somehow become invasive on American soil. In fact, most of the turtles you see today in ponds and lakes were not born from America's natural ecosystems. They come from breeding farms in China and Southeast Asia. These turtles are mass-produced on an assembly line scale, packed into boxes, and exported as $5 pets. For decades, they were the most widely kept turtle species on the planet. At the peak of production, as much as 90% of all red-eared sliders worldwide came from a single farm in Louisiana. From 1980 to 1990, this one state alone exported 52 million turtles, roughly equal to the entire population of South Korea at that time. By 1975, the Food and Drug Administration banned the sale of turtles smaller than 10.2 centimeters. But instead of reducing the trade, the ban pushed the market straight into the black market. As a result, between 5 million and 10 million baby turtles were still smuggled into circulation every year, mostly through classified ads and exotic pet fairs. A few arrests revealed just how massive the trade really was. In 2018 and 2019, Indian Customs seized 11,700 red-eared sliders from just 2 flights arriving from Bangkok. All of them were crammed into 60 small cardboard boxes, each about the size of a fruit crate, and those were only 2 lucky interceptions. Another major source of release comes from Buddhist mercy release rituals. On the surface, it sounds compassionate. In reality, millions of turtles are released every year into lakes, canals, and streams that are not their natural habitats. They spread disease, compete for food, and push out native turtle species. If you have ever seen people releasing baskets of turtles into a pond to gain good karma, it needs to be said plainly. That is a direct act of spreading invasive species. But the primary culprit is still pet owners. When purchased, the turtle is no bigger than a coin and lives in a small tank holding only 2 to 3 liters of water. A few years later, it requires a 400-liter tank or even a backyard pond. It eats a lot, produces a lot of waste, and smells extremely unpleasant. Many owners choose the quickest solution, taking the turtle to a public park and releasing it into a lake. From that point on, red-eared sliders spread to every continent except Antarctica. Today, the number of red-eared sliders living in the wild can no longer be counted. The United States, Japan, Italy, and Singapore all report that in many urban lakes, between 80% and 95% of the turtle population consists of red-eared sliders. In some locations, researchers cannot even find native turtles to study anymore. And to understand why red-eared slider turtles have exploded so rapidly, we need to look directly at the true main character of this story. At first glance, red-eared sliders really do look cute. Their small heads popping above the water, the 2 red stripes on each side of their heads looking almost like they are wearing headphones. But do not let their appearance fool you. Once they reach adulthood, this species develops a set of traits that, when you listen carefully, make it easy to understand why ecologists describe them as mini ecosystem-destroying machines. Red-eared sliders live extremely long lives. A pet turtle can live 30 to 40 years, but in the wild, lifespans of 50 to 70 years are not unusual. That means even if just a few individuals escape into the environment, they can survive longer than an entire human generation. Imagine this. Release one turtle today, and 30 years later it is still there, still reproducing, still competing for food, and still expanding its territory. Their reproductive capacity is powerful. A single female can lay 20 to 30 eggs per breeding season, and because they live so long, each turtle can produce hundreds of eggs over its lifetime. Combined with the fact that they have almost no natural predators in urban lakes, their population grows so fast that it becomes impossible to keep count. If you think 20 to 30 eggs sounds small, compare it to native turtle species, many of which lay only 3 to 7 eggs, with very low survival rates. Red-eared sliders are different. They are like marathon breeders, persistent and consistent for decades. Their courtship behavior looks both amusing and unsettling. Male red-eared sliders have unusually long claws on their front legs, but they do not use them to fight as you might expect. Instead, they use them to perform a kind of seductive hand dance. When a male encounters a female, He swims close, raises his front legs, and rapidly vibrates his claws directly in front of her face, almost like he is fanning air toward her. If you search for videos, the scene looks funny, but this behavior is one of the keys to their reproductive success. When timing is right, mating happens quickly and almost anywhere, from natural lakes to urban drainage canals. And here is the part most people do not know. Red-eared sliders can change sex based on temperature. Turtle eggs respond directly to environmental heat. Urban soil and water temperatures are often 2 to 5 degrees Celsius warmer than natural habitats, and these temperatures cause most eggs to hatch into females. You heard that correctly. A single park pond can contain 90 to 95% female turtles, which means population growth accelerates dramatically. While native turtle species maintain balanced sex ratios, red-eared sliders in cities turn into a literal female turtle factory. The final factor is aggression and territorial dominance. Red-eared sliders are not as gentle as they look. If you have ever seen turtles crowding together on a log, that is not a friendly gathering. It is strong turtles pushing weaker ones off. And in most cases, the dominant turtles are red-eared sliders. This is the primary reason native turtle species in the United States are disappearing. It is not that red-eared sliders kill off their competitors directly. Instead, they make it impossible for native turtles to survive, even without direct attacks. That may sound hard to believe, but surveys by the United States Geological Survey show that just 15 to 20 red-eared sliders in a small pond are enough to reduce native turtle populations by more than 80% within just a few years. The first reason involves basking behavior. For turtles, basking is not relaxation. It is essential for raising body temperature, killing parasites, and supporting digestion. Red-eared sliders always climb up first and occupy the best basking spots, and they become extremely aggressive when their territory is disturbed. The result is that native turtles are forced back into the water. Their body temperature drops, they weaken, grow more slowly, and experience a sharp decline in reproduction. Research in California shows that if native turtles lose just 1 hour of basking time per day, their reproductive rate drops by as much as 40%. Next comes competition for food. Red-eared sliders are extreme omnivores. They eat fish fry, tadpoles, eggs, snails, algae, and aquatic plants. Anything they can swallow. In contrast, many native species, such as the western pond turtle, are more selective, slower, and less aggressive. The outcome is clear. In a 2017 experiment conducted by Oregon State University, red-eared sliders consumed 70 to 90% of the food provided in test ponds, leaving native turtles malnourished within just the first few months. Another major issue is egg and hatchling predation. Red-eared sliders do not just compete, they actively eat the eggs and young of native turtle species. Nest destruction rates for western pond turtles in California have been recorded as high as 95%. After just a few breeding seasons, entire populations can collapse. Even worse, red-eared sliders function as mobile disease reservoirs. They carry salmonella, rhinovirus, mycoplasma, and various shell fungi. For them, these infections are usually mild, but native turtles have never evolved defenses against these pathogens. The result can be devastating. Rhinovirus alone can kill 90% of frogs, fish, and turtles in a single pond within 3 to 5 days. If you have ever heard the phrase, fish dying until the lake turns white, red-eared sliders may be one of the indirect causes. All of these factors lead to what ecologists call the complete replacement of native turtle communities. In many park ponds across California, Texas, and Florida, volunteer surveys have recorded that 90 to 95% of the turtles present today are red-eared sliders. And what makes this truly frightening is that ecosystems do not just lose native turtles. When red-eared sliders appear, the entire food chain begins to destabilize. In reality, they are so aggressively omnivorous that ecologists use the term the vacuum cleaner of freshwater ecosystems. That means they eat almost anything they encounter. Fish fry, tadpoles, juvenile frogs, freshwater snails, small shrimp, insects, the eggs of water birds, and even aquatic plants. The first consequence is that rare and endemic species are pushed to the brink of extinction. The western pond turtle, one of the last remaining native turtle species on the west coast of the United States, has declined by as much as 90% in many regions simply due to competition for basking sites and egg predation. In Australia, the Bellinger River turtle once faced near total extinction after red-eared sliders destroyed their nesting sites. In Europe, the European pond turtle, known scientifically as Emys orbicularis, reproduces very slowly. A study in Italy showed that once just a few dozen red-eared sliders appeared, 100% of Emys nests were destroyed within a single breeding season. You can see the scale of the disaster. A species that was already rare suddenly faced an opponent that simply does not get tired. Then comes the domino effect across the entire ecosystem. When turtles consume young fish, fish populations collapse. Mosquito numbers rise sharply, followed by increases in West Nile fever and encephalitis. In many American cities, mosquito infection rates have risen by as much as 200 to 300% around lakes with high densities of red-eared sliders. You would not expect a turtle to increase human disease risk, but that's exactly what happens. When frog tadpoles are wiped out, insect populations explode, damaging crops and home gardens. When aquatic insect larvae disappear, migratory birds lose their food source, leading to seasonal declines in bird populations. Researchers from the United States Geological Survey and Oregon State University have demonstrated that just 20 to 30 red-eared sliders in a small pond are enough to completely overturn the ecological balance. Next comes aquatic vegetation. Adult turtles consume between 1 and 5% of their body weight every day. In small ponds, this becomes a process of total depletion. They bite through roots, stems, and young shoots of aquatic plants, stripping away the lake's natural filtration system. The water becomes cloudy, light penetration drops, algae blooms explode, and oxygen levels fall to lethal levels. In Los Angeles, Echo Park Lake once had to spend $150,000 to treat toxic algae, and red-eared sliders were identified as one of the primary contributing factors. And the damage does not stop there. Red-eared sliders also harm agriculture. In California's Central Valley, the largest fruit and nut-producing region in the United States, turtles have been found crawling into irrigation pipes to escape heat. The result is blocked pipes, ruptured systems, and the failure of entire irrigation lines. Seasonal losses are estimated at $300,000 to $500,000. A turtle no bigger than a human hand can cause damage equivalent to a brand new car. For humans, red-eared sliders also carry serious disease risks. Multiple studies by the Centers for Disease Control and Prevention show that they are one of the strongest reservoirs of salmonella among pet reptiles. In Chicago, 70% of salmonella infections in children under 5 years old were directly linked to red-eared sliders. From 2006 to 2012, the United States recorded 473 cases of multi-drug-resistant salmonella across 41 states, all associated with pet turtles. And it is not just salmonella. Red-eared sliders also spread ranavirus, which can kill 90% of frogs and fish within 3 to 5 days, mycoplasma that causes respiratory infections, herpes virus, the fungus Ophidiomyces responsible for white-nosed snake disease, and Aeromonas bacteria that cause severe gastrointestinal illness in aquatic animals. Just a handful of red-eared sliders is enough to turn an entire pond into a disease hotspot. The total economic damage caused by red-eared sliders in the United States is estimated at between $500 million and $900 million per year, including water treatment, agricultural losses, native turtle restoration, and disease control. Globally, annual damage from this species is estimated to reach between $1 billion and $3 billion. In Taiwan, they have turned water murky and triggered massive algae blooms. In South Korea, they have destroyed traditional lotus ponds. But the most severe case is Japan, where the government has officially labeled the red-eared slider a national invasive species. Japan now spends $50 million every year on control efforts, including bans on sale, import, and ownership, and has launched a nationwide campaign urging people to return turtles to breeding centers, not release them into lakes. So if red-eared sliders cause such severe damage, why don't humans simply catch them all? The answer sounds simple, But in reality, it is almost impossible. Many U.S. states have tried organizing volunteer turtle removal day events. More than 200 people spread out around a single lake to collect turtles. But the outcome is almost always the same. They catch a few individuals, while the lake actually holds hundreds. Why? Because red-eared sliders can stay submerged for 45 to 60 minutes without surfacing, are extremely skilled at burrowing into mud, and disappear instantly at the slightest sound or vibration. Not only that, states like Florida and Louisiana have even had to hire professional divers at high wages to search for turtles in deep lakes. But the results are still ineffective. Each lake contains dozens of natural hiding cavities. Turtles are widely dispersed, and their reproductive speed is so fast that removal efforts can never keep up. Think about it. A single female turtle lays 20 to 30 eggs per season, while a team of divers may only capture a few dozen turtles per month. This battle is lost before it even begins. The idea of using poison was once proposed, but it was rejected immediately. Even a small amount of chemicals spreading through the water would kill fish, native turtles, shrimp, crabs, frogs, and even the entire microbial community. Water contamination would persist for years. In other words, to eliminate invasive turtles, authorities would have to accept destroying the entire lake. No one is willing to do that. Another option is cage trapping. From 2008 to 2015, states such as Oregon, Washington, and New Mexico deployed hundreds of traps. One well-known campaign in Oregon captured 1,200 red-eared sliders in a single season, which sounds impressive. But the following year, surveys showed that turtle numbers had not declined at all. Why? Because as long as a few dozen turtles remain, and each one lays 20 to 30 eggs, the population can recover 100% in just a single breeding season. Even worse, cage traps frequently capture native turtles, including the western pond turtle, a species already at risk. Conservation workers then have to spend time releasing them back into the wild. Some regions attempted control through laws banning the sale of small turtles, but this also failed. The Food and Drug Administration ban enacted in 1975 aimed to prevent salmonella infections in children, yet the black market continues to sell hundreds of thousands of turtles. People purchase them online from other states, or turtles are smuggled in from Mexico and Asia. Every year, between 5 million and 10 million baby turtles still enter the global pet trade. And if just 1% of owners release their turtles into the wild, new populations are immediately reestablished. Even if humans manage to remove 99% of red-eared sliders from a lake, the effort is still meaningless. These turtles live 30 to 40 years, and if just 2 adult individuals remain, they can reproduce and fully restore the population within 2 to 3 years. This is why the International Union for Conservation of Nature has classified the red-eared slider as a globally invasive species, among the most difficult organisms on Earth to control. But the story does not end there. What no one expected was that a single alligator reintroduction program would turn into a comprehensive solution capable of addressing 2 major problems at once. Americans did not intentionally release alligators to eliminate turtles, yet a 30-year alligator conservation program accidentally created an ecological shield so powerful that red-eared sliders simply could not withstand it. To understand why the return of alligators completely changed the battle, you need to know this first. The American alligator once stood on the very edge of extinction. Between 1910 and 1960, alligators were hunted relentlessly for their skins. Wetlands were drained, canals were polluted, and thousands were shot simply because people believed they were dangerous. By 1967, the American alligator was officially listed under the Endangered Species Act. It then took 20 years, from 1967 to 1987, for the United States to bring the species back from the brink. The government banned hunting, built large-scale breeding facilities across Louisiana, Florida, and Mississippi, reintroduced alligators into restored wetlands, expanded protected marshland, and launched community campaigns such as Alligator-Friendly Rivers. This became one of the greatest conservation victories in United States history. And that very success unexpectedly turned into a natural weapon against red-eared sliders. Starting in the 1990s, American alligators began returning to the Florida Everglades, the bayous of Louisiana, the wetlands of Georgia, and the marshes of Texas. At the same time, from 1990 to 2005, red-eared slider populations exploded due to cheap pet trends and widespread release after owners could no longer keep them. These two opposing trends collided, and alligators became the most effective turtle predators on the planet. According to studies from the University of Florida, the Louisiana Wildlife Department, and the Journal of Herpetology published between 2013 and 2020, the bite force of an American alligator reaches between 13,000 and 16,000 newtons, 2 to 3 times stronger than a lion's bite, and powerful enough to crush the shell of an adult turtle. But the most surprising fact is this: red-eared sliders have no instinctive fear of alligators. Native turtle species in the United States, such as cooters and native sliders, evolved alongside alligators for more than 10,000 years. They know how to avoid dangerous basking sites, adjust their activity hours, and stay away from waters where alligators hunt. Red-eared sliders, especially those released from urban ponds, have no such danger map in their brains. They climb onto any log or shoreline, often directly within alligator strike range. You can imagine the scene. Native turtles stand on higher, safer basking logs, while red-eared sliders crowd along the water's edge, where alligators can lunge at any moment. And exactly as expected, juvenile turtle predation rates rise sharply in wetlands with alligators. A survey by Florida Fish and Wildlife Conservation Commission found that 60% of hatchling turtles in alligator-inhabited areas were eaten within their first year. But what makes this fascinating is not just who eats whom. Like the wolf and elk effect in Yellowstone, alligators create a psychological, ecological effect. When alligators are present, red-eared slider populations decline by 35 to 60%, even when alligators do not physically eat them all. The mere presence of alligators, or even artificial alligator head models placed on the water's surface, is enough to drive red-eared sliders away from basking sites, reduce mating, and suppress egg-laying. You heard that right. Sometimes just the shadow of an alligator is enough to cut red-eared slider reproductive output by 50%. Of course, alligators do not always win. There are moments of what could only be called ecological comedy. One video filmed in Fakahatchee Strand Preserve State Park went viral with more than 3.4 million views. In the footage, a massive alligator attempts to crush a turtle's shell, but after nearly a minute of effort, it gives up. A turtle's shell is armor formed from nearly 50 fused bones, so strong that even a car driving over it may fail to break it. Some turtle species in the United States also have smooth keratin layers, almost like raincoats, causing alligator bites to slide off repeatedly. So even though alligators are the lords of the swamp, sometimes they have to accept defeat. In contrast, there are scenes that look completely absurd. Turtles rushing in to steal food directly in front of an alligator's jaws, and the alligator retreats. This shows that ecosystems are not simply about bigger animals defeating smaller ones, but about strategic interactions between species shaped by millions of years of evolution. But red-eared sliders do not cause damage only through competition or vegetation destruction. They also carry at least 6 types of pathogens capable of wiping out entire native populations. The United States Geological Survey has documented red-eared sliders carrying multi-drug-resistant salmonella, ranavirus that can kill 90% of fish and frogs within 3 to 5 days, mycoplasma that causes respiratory infections, herpes virus that leads to shell lesions, Aeromonas bacteria that cause severe diarrhea in aquatic animals, and the fungus Ophidiomyces, responsible for white-nose disease in snakes. This is why alligators become such an important natural defense line, because they stop red-eared sliders before these diseases can spread throughout wetland ecosystems. So, has any state ever released alligators to control red-eared sliders? The answer is no. There is no official policy or document instructing the release of alligators for turtle control. However, Louisiana, Florida, and Georgia, through long-term alligator restoration, unintentionally created an extremely effective model. Alligators became the middle enforcer, helping ecosystems regain natural balance in the way they have functioned for thousands of years. But after realizing that red-eared sliders flee the moment they sense the presence of an alligator, researchers in South Carolina and Florida decided to test a solution that sounded almost like a joke, but turned out to be surprisingly effective, placing fake alligators into lakes. These were not sophisticated art installations. They were simple alligators, made of plastic or composite foam. Sometimes it was nothing more than a floating alligator head, equipped with a small camera to monitor turtle behavior. The team tested 3 types of decoys: battery-powered robotic alligators that moved slowly across the water surface, plastic alligator heads with reflective eyes, fixed and fixed predator decoys placed at strategic locations. The results were so dramatic that the researchers initially rechecked their data, assuming they had made a calculation error. After just 2 to 3 weeks of deployment across 12 urban lakes, red-eared sliders declined by 80 to 90% at basking sites. In contrast, native turtles continued climbing onto their usual basking spots, showing no signs of fear. The ecosystem responded almost immediately. Small fish returned to shallow waters, soft aquatic plants began to regrow, and water clarity improved as destructive grazing pressure dropped. The United States is not the only country using predators to control red-eared sliders. After the effects of real alligators and fake alligators proved clearly effective, many other countries began identifying their own native natural enemies. Japan is the most striking example. They did not release alligators, did not use artificial decoys, and did not pour money into chemicals. Instead, they chose an approach that sounds both delicately Japanese and remarkably effective. Introducing native hawks into public parks on fixed schedules. From 2020 to 2023, Japan's Ministry of the Environment conducted pilot programs in Koshigaya Park, in Saitama, and in lake regions of Shizuoka. Over 4 decades, Japan imported more than 5 million red-eared sliders from the United States, leading to a 70% decline in the native Japanese pond turtle, Moramis japonica. Urban ponds were completely overtaken by red-eared sliders, soft aquatic plants died off, and young fish disappeared. Imagine a peaceful Tokyo park, while beneath the water surface an army of invasive turtles swarms unseen. No one expected that simply allowing a Harris's hawk or a gray-faced buzzard to patrol for 2 to 3 hours per day would be enough to prevent red-eared sliders from climbing onto basking sites. After 8 months of testing, red-eared slider populations declined by 32 to 45%, while native turtles returned to their original basking areas as if saying, "We were here first." Why was this so effective? Because red-eared sliders never evolved alongside Asian hawks. Native Japanese turtles know how to hide, how to wait, and how to emerge only after predators leave. Red-eared sliders, by contrast, have almost no defensive instincts. The moment a bird's shadow passes over the water, they dive instantly. This shows a simple truth: an invasive species only thrives when an ecosystem is missing a key piece. Once that piece, the predator, is restored, the system begins to correct itself. In Italy, the solution took on a more practical European character. They did not use birds or artificial alligators. Instead, they relied on a native species, the European eel. European eels are highly effective nocturnal predators of turtle eggs and hatchlings. When eel populations collapsed due to pollution, red-eared sliders exploded like wildfire. But when Italy reintroduced eels into lakes across northern regions such as Veneto and Lombardia, hatchling turtle numbers dropped by 20 to 40%. Small fish returned and waterbird nesting sites became safer. If you walk along an Italian lake, you will not see the eels. But every night they work silently along the bottom, consuming red-eared slider nests that humans could never reach. Even more remarkable, Italy also reintroduced the native European pond turtle, Emus orbicularis, a weaker competitor on land but faster in water, more cold-tolerant, and better at choosing deeper nesting sites. When approximately 200 to 300 Emus individuals were released, red-eared sliders declined by 25 to 35%, while Emus reproduction increased by 3 to 4 times. This is one of the rare cases worldwide where internal ecological competition was used to defeat an invasive species. It may sound strange, using turtles to fight turtles, but in this case, native residents confronting a biological squatter. Australia, unsurprisingly, followed an approach that was distinctly Australian. Instead of birds or alligators, they released Murray cod, the largest freshwater predator in Australia. Adult Murray cod reach lengths of about 1.3 meters and weigh between 70 and 100 kilograms. With jaws as wide as a small bucket, they can swallow almost anything that fits: fish, water snakes, and even young turtles. Australia faces invasions from 3 non-native turtle species: red-eared sliders, yellow-bellied sliders, and striped-necked turtles. These species destroy waterbird nests, chew through lotus roots, and consume young fish. But when Murray cod were reintroduced into the Murray River, Lake Hume, and Lake Eildon, invasive turtle populations declined by 38 to 55% within just 2 to 3 years. Algae levels dropped, small fish recovered, and wetland ecosystems showed a clear increase in biodiversity. Around the world, humans are now using every possible method, from real alligators and fake alligators to Japanese hawks, Italian eels, and Australia's giant Murray cod, just to fight back against a species that was once sold as a pet for $5. Red-eared sliders are not villains, but they are a powerful reminder that even a single small human mistake can be enough to disrupt an entire ecosystem. So what do you think? Which country has come up with the smartest solution? And are there invasive species even more dangerous than the red-eared slider? Share your thoughts in the comments below, and don't forget to subscribe to the channel for the next episode. Today, we are talking about a creature that destroyed the Great Lakes. Just one single species caused damage equal to 5 times the entire United States commercial fishing industry combined. It attaches itself to a host, feeding parasitically, and sucking blood until the prey is completely drained and dies. More than 100 million fish have been killed, and the number continues to rise. The pressure to eliminate it became so extreme that people tried everything, from encouraging the public to eat this invasive species to pouring chemical treatments into rivers continuously for 60 straight years. Yes, you heard that right, but the problem is, it still has not disappeared. And this is the story of the most terrifying invasive species eradication campaign in the history of the Great Lakes. Have you ever imagined a creature that looks like an eel, with no jaws and no tail fin, yet clings to other fish and sucks their blood like a vampire? It sounds like something out of a horror movie, right? But this creature is real. It is the sea lamprey, an ancient species that has lived on Earth for more than 360 million years. Yes, it existed even before the dinosaurs. At first glance, a sea lamprey looks like a long eel. But wait, imagine a body that can reach a length of 90 to 120 centimeters, smooth like an underground power cable, with a diameter of only about 2.5 centimeters, roughly the width of an adult human wrist. Along both sides of its neck are 7 gill openings that look exactly like 7 bullet holes punched straight through its body. But the most disturbing feature is its mouth, as wide as its head and capable of locking tightly onto its prey. Inside are more than 100 sharp, saw-like keratin teeth arranged in a circular ring with a needle-like tongue at the center. When attacking, the sea lamprey uses this tongue to drill straight through a fish's scales, then continuously sucks blood and bodily fluids. Once attached, a sea lamprey can remain parasitic for up to 2 months. Its body contains more than 100 mucus glands that secrete a slippery coating, making it extremely difficult for predators such as sharks to grab hold of it. The life cycle of the sea lamprey is so strange that, at seeing it, you might think you are looking at 2 completely different species. When they first hatch, the larvae, called amicoetes, have no teeth and no suction mouth. They are small, brown creatures buried in river mud, quietly filter feeding on algae and debris. This hidden stage lasts from 3 to 7 years and is completely harmless. When metamorphosis begins, nearly the entire body changes. Eyes develop, a round suction mouth appears, keratin teeth grow in, and the digestive system shifts to a blood-feeding parasitic lifestyle. Some populations have even adapted to survive in both freshwater and saltwater. Even more remarkable, sea lampreys can change their sex, determining whether they become male or female, based on environmental conditions and population density. To better understand this transformation, a research team led by Nick Johnson conducted experiments in tributaries of the Great Lakes system. They selected streams that had been confirmed to be completely free of wild sea lampreys, then released between 1,500 and 3,000 larvae into them to observe how they developed and underwent metamorphosis. Most importantly, while this species is classified as endangered in Europe and the northwestern Pacific, in the United States, especially within the Great Lakes system, the name sea lamprey is tied to an unresolved ecological nightmare. But we will come back to that later. First, you need to understand this. Humans directly opened the pathway that allowed sea lampreys to move from the Atlantic Ocean deep into the Great Lakes. Their invasion began so quietly that, without historical records, you might think the story was made up. Starting in the 1830s, sea lampreys followed Lake Ontario and slipped through the Erie Canal, gradually pushing into the largest freshwater lake system in North America. At the time, no one paid attention, because people believed one thing. Niagara Falls, nearly 50 meters high, was the perfect natural shield, blocking any creature from swimming upstream from the Atlantic. Just imagine it. 12,000 years of nature designing a solid barrier, undone by a single human decision. In 1919, when the Welland Canal was upgraded to allow ships to bypass Niagara Falls, we accidentally created an ecological highway 90 meters wide, deep enough for large vessels, and of course more than enough for sea lampreys to swim straight into the heart of the Great Lakes. From that point on, everything spiraled out of control. Soon after entering Lake Erie, sea lampreys spread into Lake Huron and Lake Michigan at a speed scientists later described as impossible to keep up with or warn against. And by 1938, they had reached Lake Superior, the largest, deepest, and coldest lake in the entire system. What matters is this: the entire process is clearly documented in reports from the Great Lakes Fishery Commission and the United States Geological Survey. This is not rumor. It is not exaggeration. This is real data. In just a few decades, a jawless fish, less than 1 meter long, penetrated more than 1,000 kilometers into the interior of North America. So how did they begin attacking fish here? First, to put you at ease, sea lampreys do not attack humans because their suction strength is not powerful enough to penetrate our thick, tough skin. But for large fish, especially species with thin skin and dense blood vessels, sea lampreys are a true nightmare. Imagine their mouth as a high-powered vacuum cleaner, but instead of a normal suction head, it is armed with more than 100 razor-sharp teeth, each like a tiny saw blade. When a sea lamprey attaches to a fish, the suction is so strong that researchers must use both hands to pull it off, even when it is attached only to a smooth glass surface in a laboratory. On the soft skin of a live fish, you can imagine the result. Escape is almost impossible. Once firmly attached, the saw-like tongue inside the mouth begins scraping away layer after layer of skin and flesh from the prey, much like using sandpaper on a piece of fruit. The result is a perfectly round wound, coin-sized, and so deep that the underlying tissue is exposed. What makes this even more terrifying is that sea lampreys release an anticoagulant in their saliva, preventing the wound from clotting and causing it to bleed continuously for hours, sometimes even days. You have probably cut your finger before and watched the blood clot within minutes. Now imagine a creature that cannot clot at all, bleeding until it is completely exhausted. That is what happens to a sea lamprey's victim. Over the course of its parasitic life, a single sea lamprey can drain up to 18 kilograms of nutrients from its host, nearly the body weight of a 5-year-old child, while the lamprey itself is less than 1 meter long, and it does not know how to let go. A sea lamprey does not take a few sips and swim away. It stays attached until the fish dies from blood loss, infection, or sheer exhaustion, and sinks to the bottom of the lake. In the Atlantic Ocean or in Europe, the damage caused by sea lampreys is kept in check by natural predators such as seals and large fish. But the Great Lakes are different. No species there evolved to defend against this kind of attack, leaving the ecosystem completely unprepared for this invader. To put it into perspective, Lionfish took about 40 years to disrupt the Caribbean ecosystem, while sea lampreys needed only 15 years to kill more than 100 million large fish in the Great Lakes. A single sea lamprey killed fish at a rate 5 times greater than the entire commercial fishing industry of that era combined. You did not mishear this. The greatest disaster did not begin across the entire Great Lakes system. It started in one single place, Lake Erie. From there, everything spread so fast that ecologists later described it as a chain collapse with no breaks. Lake Erie became the first victim because it sits directly behind the Welland Canal, the doorway humans unintentionally opened. Just a few years after sea lampreys appeared, the entire population of predatory fish in Erie began to collapse rapidly. To put this into perspective, in less than 2 decades, sea lampreys killed more fish than the entire United States commercial fishing industry combined. A single lamprey can drain up to 18 kilograms of nutrients from its host over its parasitic lifetime, each one killing between 18 and 20 large fish. And all of these figures were officially recorded by the Great Lakes Fishery Commission. They are completely real. At that time, Lake Erie looked like a system stripped of the top layer of its food chain. Lake trout, whitefish, and walleye, the most critical species, nearly vanished from the ecological map. The consequences were immediate. Small fish populations exploded, algae grew out of control, and water clarity and nutrient levels changed dramatically within just a few years. This was the first place where scientists recorded an ecosystem that was entirely defenseless against a cling-until-death form of parasitism that had never existed in freshwater before. Only after Erie collapsed did the shockwave spread to the other lakes. In Lake Huron, lake trout harvests fell from 3.4 million pounds in 1937 to nearly zero by 1947. In Lake Michigan, production dropped from 5.5 million pounds in 1946 to just 402 pounds in 1953. So little that the entire annual catch could fit inside a single small truck. In Lake Superior, yields declined from 4.5 million pounds to 368,000 pounds by 1961. It was not only large fish that were wiped out. Native Cisco species such as Coregonus alpinae, Coregonus johannae, and Coregonus nigripinus went completely extinct, something that had never happened before in the history of the Great Lakes. In the ocean, sea lampreys are still controlled by seals and large predatory fish. But here, there were no natural enemies. No freshwater species had ever evolved to counter this kind of parasitism. And once the top predators were erased, alewife populations exploded, then crashed, dying in massive numbers and washing ashore in piles, turning beaches white with rotting fish and filling the air with stench throughout the summer. By 1980, the recorded economic damage exceeded $500 million per year, leaving thousands of fishing families without a livelihood. From this point on, pressure from fishing communities, local governments, and industries dependent on freshwater ecosystems exploded. When fish harvests collapsed to nearly zero, authorities realized one thing. If sea lampreys were not eliminated immediately, the entire Great Lakes system would turn into a massive dead lake. That was the moment humanity struck back, and struck back literally, trying every method imaginable. Sea lampreys became the first invasive species in history that forced the United States to create an international organization dedicated to fighting just one single species. In 1954, under the pressure of economic losses and ecological collapse, the United States and Canada, together with 8 states and multiple indigenous tribes, signed an agreement to establish the Great Lakes Fishery Commission. In reality, the early control efforts were complete failures. Local authorities built barriers across streams, stretched massive steel nets, and installed electric shock devices to stun lampreys. But the sea lampreys kept getting through. They needed only a gap the width of a finger to spread farther. Officials soon realized that to win, they had to strike at the true weak point, killing the larvae before they could transform. Do you remember the lamprey life cycle? 5 to 6 years spent buried in streambed mud, completely invisible, with no suction mouth. Once they matured and swam out into the lakes, it was already too late. So the only target was to destroy them inside the streams themselves. That marked the beginning of the most extreme quest in North American ecology, finding a chemical that could kill sea lampreys, and only sea lampreys, without harming native species. Years of experiments followed, lasting 7 years at the University of Michigan and the Hammond Bay Biological Station. Scientists immersed different fish species into chemical solutions like pickled vegetables, literally. They called this the pickle jar test. Native fish were placed into the same solution as lamprey larvae to see which died first. The results were horrifying. Most chemicals killed everything without distinguishing friend from foe. Then one day everything changed. A compound called 3-trifluoromethyl-4-nitrophenol, known as TFM, produced results so strange that researchers did not know how to describe them. In laboratory notebooks from that time, they wrote only one word: remarkable. TFM killed sea lamprey larvae almost instantly, while native fish were barely affected. The reason was shocking. The 350-million-year-old lamprey body had never evolved the ability to metabolize TFM, while most modern fish species possessed enzymes capable of processing it. During the 1950s and 1960s, control teams traveled across shallow streams, pouring liquid TFM into waters only a few feet deep. Lamprey larvae buried in the streambed were poisoned and died in massive numbers, while native fish continued swimming above. But a major problem appeared immediately. Deeper waters remained a safe refuge. There was not enough TFM in the world to treat rivers like the St. Mary's River. Too wide, too deep, and carrying too much water. TFM solved only about half of the problem. In 1990, humanity deployed a second heavy weapon against sea lampreys, niclosamide, a toxic compound that sinks to the bottom, releases slowly, and targets the exact zone where larvae hide. Combined, these two chemicals formed the most powerful freshwater invasive species control strategy ever used. Each chemical targeted a different water layer, without overlapping or canceling each other out. To this day, the Great Lakes Fishery Commission still relies on this formula. TFM for shallow streams, niclosamide for deep bottoms, and physical barriers to block migrating adult lampreys. Few people realize that this strategy was once nearly abandoned. In the 1970s, the Environmental Protection Agency almost banned lampricides due to concerns that TFM might harm amphibians and microorganisms. The debate lasted 15 years, until scientists proved that TFM nearly exclusively killed lamprey larvae and had minimal impact on native species. They won. Had they lost, the Great Lakes might have collapsed a second time. Many people believe humanity has already won, but that is not true. During the years 2020 to 2021, because of the COVID-19 pandemic, only 25 to 75% of planned lampricide treatments were carried out. That 2-year gap was enough for an entirely new generation of sea lampreys to surge. When treatments resumed in 2022, the Great Lakes Fishery Commission eliminated approximately 8.5 million lampreys per year, and numbers began to decline. But by 2024, a major plot twist emerged. Lake Superior exceeded its safe threshold by 5 times, while Lake Michigan and Lake Huron surpassed targets by thousands to tens of thousands of individuals. Only Lake Erie remained below the danger line. We must accept a hard truth. We cannot eradicate sea lampreys. We are only holding their heads underwater. Ease up for just a few seasons, and they surge back to the surface. The reason eradication is nearly impossible lies in their long life cycle, which lasts up to 7 years, with 5 to 6 years spent as larvae buried deep in mud, completely invisible to modern technology. On top of that, a single female sea lamprey lays 100,000 eggs, with roughly 75% successfully hatching. They survive in waters ranging from the cold of Lake Superior to the warmth of Lake Erie. Most importantly, they adapt with terrifying speed. When TFM targets shallow streams, they begin shifting deeper. When niclosamide attacks the bottom, they learn to spread out along the current. Do you remember? In their native home, sea lampreys are not mass killers. In fact, in Europe and parts of the Pacific, many populations are now classified as endangered, not because they swam all the way to the United States, but because humans ate too many of them. In places where coevolution occurred, such as France, Portugal, and England, sea lampreys live as parasites without necessarily killing their hosts. Native fish there have evolved over millions of years to tolerate this form of blood feeding. The situation in the Great Lakes, however, is completely different. In medieval France, sea lampreys were even called food for the nobility. The dish lamproie à la bordelaise, lamprey cooked in Bordeaux wine, was once served at royal banquets. In England, the tradition of making lamprey pie was so important that the city of Gloucester was once fined for failing to deliver a lamprey pie to the king on time. Legend even says that King Henry I died from eating too many lampreys, a death so famous that the phrase, "a surfeit of lampreys," entered the history books. Today in Europe, lamprey dishes still exist, but in more refined forms. Charcoal grilled lamprey with rich, chewy flesh similar to eel, lamprey soup in England, or smoked preparations served at local festivals. You might be surprised to learn that in traditional medicine, lampreys were also used as remedies. Although modern science has not fully verified these uses, so extreme caution is required. So why not apply the idea of eating the invasive species to save the ecosystem, like Italy is doing with blue crabs, or Hawaii with feral cattle? The answer is very practical. First, the scale of the sea lamprey population in the Great Lakes is far too large. Human consumption can never keep up with their reproduction rate. You simply cannot eat away an army of millions every year. Second, the mindset of Americans and Canadians is very clear. To them, this is not a royal delicacy, but a blood-sucking demon that wiped out their ancestors' fishing industry. Asking them to eat sea lamprey is like asking Australians to eat poisonous cane toads. And third, the most important reason, most sea lampreys in the Great Lakes live in waters treated with lampricides, such as TFM and niclosamide. No one wants to put an animal that has been soaked in parasite-killing chemicals into a soup pot. In reality, beyond viewing them as food, sea lampreys possess something far more extraordinary: the ability to regenerate their nervous system. In humans, when the spinal cord is severed, it is almost the end of motor function. No dogs, cats, or any modern vertebrates can do much better. Sea lampreys, however, are completely different. Research from the University of Michigan and the National Institutes of Health shows that in just 10 to 12 weeks, all severed spinal cord connections in sea lampreys regrow 100% on their own, fully restoring motor function. This is an ability that human medicine, despite all its technology, machines, and modern laboratories, still cannot replicate. The secret lies in their primitive brain. A sea lamprey brain contains only about 2,000 to 3,000 neurons, hundreds of thousands of times fewer than the human brain. If the human brain is a supercomputer with 86 billion neurons, then the sea lamprey brain is like an ancient pocket calculator, so simple that scientists can observe every electrical impulse as it travels, every connection as it forms, and every spinal cell as it regenerates. That very simplicity is what makes sea lampreys such a valuable model, helping researchers understand the fundamental mechanisms of nerve regeneration, how neural signals recover after injury, and even how the brain generates behavior. In addition, the sea lamprey immune system is an evolutionary treasure. Remember, these creatures first appeared more than 360 million years ago, preserving early prototype forms of many modern immune molecules. To biologists, sea lampreys are like a time portal, allowing them to look back to the moment when the vertebrate immune system was just beginning to take shape. Returning to the Great Lakes, sea lampreys once came dangerously close to escaping the system altogether. In 2017, during a routine biological survey, scientists detected sea lamprey DNA in a tributary of the Mississippi River. It was only genetic traces, not an actual fish, but that alone was enough to trigger a red alert. If you understand how vast the Mississippi River is, you will immediately see why this news sent shockwaves through the American ecology community. The river stretches across 20 states, supports dozens of major river cities, and connects a freshwater system covering up to 3.7 million square kilometers. In other words, if sea lampreys were to enter this system, the entire United States, from north to south, would effectively be open to them with no natural barriers. The Great Lakes would have been only the opening act. That is exactly why sea lamprey control efforts after 2017 were escalated to a scale resembling a military operation. If earlier phases saw the Great Lakes Fishery Commission attacking from every direction, chemicals, barriers, and traps, by 2024, the level of deployment had become even more extreme. In an official report, they documented treatment of 84 tributaries with lampricides and the clearing of an additional 22 still water areas. They operated 73 migration barriers, combining purpose-built barriers with modified structures to block every possible route sea lampreys could swim through. And it did not stop there. Crews surveyed 421 tributaries and 69 still water areas, effectively inspecting nearly every meter of water in the entire system. To estimate adult lamprey density, they set traps in 29 tributaries, continuously monitoring even the smallest migration events to determine whether any individuals had slipped past the control network. To conclude, the story of the sea lamprey reveals a hard truth that is not easy to accept. Nature does not always lose to humans, and modern technology is not always enough to fix our mistakes. A single fish less than 1 meter long once collapsed a multi-billion-dollar fishing industry, forced the United States and Canada to create an entire binational organization just to deal with it, and required hundreds of control operations every year, killing millions of sea lampreys simply to keep the situation from getting worse. As long as sea lampreys continue to exist, the Great Lakes will never be truly safe. Yet here lies the paradox. The very creature responsible for this destruction is also opening new doors for medicine, from spinal cord regeneration to uncovering the origins of our immune system. So what should the future look like? Will humans eventually wipe out sea lampreys completely, or will we be forced to learn how to live with them? Should we continue pushing for total eradication, or begin exploring their biological value? And perhaps the most unsettling question of all, what happens if sea lampreys truly escape into the Mississippi River system? Leave your thoughts in the comments below, and do not forget to subscribe to the channel so you do not miss our upcoming documentary films. You are looking at one of the most beautiful fish on the planet, but do you see their spines? They are not gentle at all. Yes, lionfish are considered one of the most aggressive invasive species in the Western Atlantic and the Caribbean. Each adult lionfish carries 18 venomous spines, 13 dorsal spines, 3 anal spines, and 2 pelvic spines, all of which are directly connected to venom glands inside the body. With just a single touch, even by accident, protein-based venom is immediately injected into your skin, causing intense burning pain, nausea, and severe muscle spasms. Although it is not fatal, the pain is so extreme that many divers describe it as being stung by 10 bees would be better than stepping on a lionfish once. Lionfish are larger than you might think. When fully grown, they average between 35 and 47 centimeters in length, much larger than many common Caribbean reef fish, such as butterfly fish or damselfish. The largest lionfish ever recorded weighed up to 1.4 kilograms and was caught by an American fisherman. One fascinating fact about lionfish is that some species living in deep waters are capable of bioluminescence, an extraordinary adaptation that allows them to produce their own light. This ability is believed to be used for communication between lionfish or to attract prey in the deep darkness of the ocean. Like salmon and carp, lionfish have thin, oval, spiral-shaped scales with smooth edges. The name lionfish comes from their resemblance to the majestic mane of a lion. Unlike lions on land, red lionfish are incredibly colorful, with wide, fan-like dorsal fins resembling feathers, long pectoral fins shaped like hand fans, and bold red, brown, and white stripes that stand out even among vibrant coral reefs. Because of this striking appearance, they are highly sought after in the aquarium trade, from their native Indo-Pacific waters to the Atlantic Ocean and even the Caribbean. And do you know what is even more surprising? Almost all lionfish in the Caribbean today share a common origin from fewer than 10 original individuals, according to genetic data published by the United States Geological Survey. Yes, in short, they all come from the same source. The first hypothesis is the most widely mentioned incident, Hurricane Andrew in the year 1992. This Category 5 storm destroyed an entire aquarium facility in Biscayne Bay and released 6 lionfish into the ocean. 6 fish does not sound like much, right? But do not forget this. A single female can produce an enormous number of eggs, and very quickly, but we will analyze that later. For now, You only need to know that all of those eggs drift freely with the Gulf Stream. The National Oceanic and Atmospheric Administration recorded that just 10 years after the incident, lionfish had appeared along more than 7,000 kilometers of coastline, from North Carolina to Venezuela, and then spread further to Cyprus, Greece, and Israel. In the world, very few invasive species have managed this, aside from the morning glory vine in Hawaii or rabbits in Australia. But the story does not end there. The National Oceanic and Atmospheric Administration states that the most likely hypothesis actually points to aquarium owners themselves. From the late 1980s to the early 2000s, the United States imported tens of thousands of lionfish from Indonesia and the Philippines to sell in aquarium shops. And when these fish grew too fast, ate too much, or became too dangerous to keep, many people chose the simplest option, taking them out to sea and releasing them. You can see how terrifying this kind of carelessness is similar to someone releasing a few Burmese pythons in Florida, and now the Everglades has become an ecological disaster. The third hypothesis is rarer but still possible. Lionfish eggs were transported in the ballast water of cargo ships traveling from Asia to the United States. Lionfish eggs have a protective, gelatinous coating, float within the water column, and can survive for many days, more than enough time to complete a long voyage. This possibility is lower, but not impossible. A cargo ship traveling from the Indian Ocean to the Atlantic could carry thousands of planktonic organisms without anyone ever knowing. No matter what the exact origin is, the conclusion does not change. This is the largest accidental invasion in the history of the Caribbean Sea. Such a small starting group, yet it created a disaster that spread in less than 10 years. At first, only a few small fish species disappeared. Then entire sections of coral reefs became unnaturally silent. And by the time humans understood what was happening, it was already too late. Lionfish do not just hunt small fish. They hunt everything they can find. The National Oceanic and Atmospheric Administration has documented that they consume more than 50 species of fish and invertebrates, from butterfly fish, damselfish, and juvenile surgeonfish, to shrimp, crabs, and even extremely toxic species, such as pufferfish, that contain tetrodotoxin, a toxin 1,200 times more potent than cyanide. Yes, a fish once considered part of the reef scenery can eat one of the most poisonous creatures in the ocean, something almost no other species can do. Even more terrifying, a lionfish's stomach can expand up to 30 times its normal size, meaning it can swallow prey continuously without resting. The National Oceanic and Atmospheric Administration has recorded a single individual consuming 20 small fish in just a few minutes, like a living vacuum cleaner sweeping an entire area clean. When food becomes scarce, they even resort to cannibalism, large lionfish eating smaller ones, a behavior you might expect from piranhas, but never from a fish often seen as slow and peaceful, like the lionfish. And it does not stop there. Despite having large stomachs and the ability to eat massive amounts, lionfish can also survive for 3 months without food and not die, losing only about 10 to 12% of their body weight. A species that can eat almost everything and barely needs to eat at all, do you think any ecosystem can withstand a creature like that? The consequences of this unmatched predatory ability have been clearly documented by research. Oregon State University reports that commercial fish biomass can decline by 65 to 95% within just 2 years after lionfish appear on a coral reef. In the Bahamas, catches of snapper and grouper, the two most valuable income sources for fishermen, have dropped by up to 70%. Imagine an entire city losing 70% of its wholesale markets within 12 months. Every dependent industry would collapse. In Belize and Honduras, economic losses are estimated at 20 to 40 million United States dollars per year, not including rising fuel costs, as fishermen are forced to travel farther to find areas not yet cleaned out by lionfish. But the greatest damage is not the loss of fish, it is the collapse of coral reefs, the foundation of the entire marine ecosystem. When algae-eating fish are wiped out by lionfish, algae grows uncontrollably, smothering corals layer by layer like mold. Corals suffocate, lose light, cannot photosynthesize, and die. A study in the year 2020 revealed something even more alarming. Lionfish also eat juvenile corals before they can attach to rock, meaning they are not only killing existing reefs, but also destroying their future generations. From vibrant coral ecosystems, the Caribbean slowly turns into a coral graveyard in just a matter of months. The domino effect follows immediately. Juvenile fish disappear, large fish lose their food and abandon the area. Dead reefs offer no shelter, forcing species to migrate or face local extinction. The National Oceanic and Atmospheric Administration confirmed through experiments that just one lionfish can reduce juvenile fish populations by 79% within 5 weeks. And when ecosystems collapse, economies collapse with them. Tourism is directly affected. A healthy coral reef can generate $1 million United States dollars per square kilometer per year from diving tourism. But when reefs die, visitor numbers drop by 30 to 90%. In Bonaire, often called the diving paradise of the Caribbean, annual revenue has fallen by as much as 24 million United States dollars. Total losses across the Caribbean are estimated at 200 to 350 million United States dollars per year, with projections reaching 1 billion United States dollars within the next 10 to 15 years if the invasion is not brought under control. When people see the scale of destruction caused by lionfish, the natural question is, so did humans do nothing? The bad news is, we did. We did a lot. And yet, it has changed almost nothing. The first and most common approach is sending divers down to hunt lionfish. The weapons sound very low-tech: Hawaiian slings, short spears, and handheld spike tools. But make no mistake, this is not a game. In many places, hunting lionfish requires permits, training on how to approach without breaking coral, and, most importantly, knowing how to handle their 18 venomous spines. One wrong touch is enough to cause hours of intense pain. The biggest limitation, however, is depth. Divers are effective only at depths of about 20 to 30 meters. While the National Oceanic and Atmospheric Administration has recorded healthy lionfish populations living as deep as 305 meters, roughly the height of the Eiffel Tower turned upside down underwater. In other words, humans are hunting on the ground floor, while most lionfish are hiding in the basement. More importantly, a few hunters are never enough. So what if many more people join? The Caribbean and Florida did not give up. The Emerald Coast Open, the largest lionfish hunting competition in the world, became an annual event. In the year 2023, 144 divers from across the United States participated and removed a record 24,699 lionfish in just 2 days. That means nearly 10 lionfish were eliminated every minute. One elite diver even set a record by catching 60 lionfish in a single dive. That sounds impressive, right? But here's the reality. A single average reef can hold 1,000 to 5,000 lionfish. So what are we really doing? Skimming foam off the surface of a boiling pot? Some people suggested traps, but the ocean does not cooperate so easily. Traps left underwater for weeks mostly caught native species, snapper, grouper, lobsters, while lionfish stood nearby, untouched. Most trapping projects were abandoned within months because they caused more harm than good. So what about robots? Several organizations tested autonomous lionfish hunting robots, but the cost per unit ranged from 50,000 to 200,000 United States dollars, and the irony is painful. Even the robots could not dive as deep as lionfish. When nearly every method failed, the Caribbean turned to a solution that sounded both strange and almost humorous: eating them. The Eat Lionfish Save Reefs movement spread across Venezuela, Mexico, Honduras, Jamaica, and the Florida Keys. People were encouraged to hunt lionfish and bring them straight to the kitchen. And surprisingly, lionfish meat is delicious, white, firm, low in bones, similar to grouper, and completely safe to eat. Only the tips of the spines contain venom. The rest of the fish is harmless. Top Caribbean chefs began adding lionfish to their menus: lionfish ceviche, lionfish tacos, pan-seared lionfish fillets, and even lionfish carpaccio, a luxury dish in high-end restaurants selling for 20 to 30 United States dollars per kilogram. If you travel to the Caribbean today, you might witness a remarkable scene. Divers hunt lionfish in the morning, and in the evening you eat that same fish at a seaside restaurant. Many tourists even see this as an eco-experience, hunting an invasive species to help save coral reefs. It sounds perfect, but there is one simple haunting problem. Humans eat too slowly, and lionfish reproduce far too fast. And if you are wondering, why is it that even after humans have hunted them, eaten them, trapped them, and even used robots, the lionfish population still increased 1,000 times in just 15 years? The answer can be summed up in a single word: reproduction. Every effort we make becomes meaningless because lionfish reproduce at a rate that is beyond the imagination of even the most experienced ecologists. A mature female needs only 2 to 4 days between each spawning. Each batch contains between 10,000 and 30,000 eggs. Over the course of a single year, that adds up to as many as 2 million eggs per female. Yes, just 1 year of reproduction equals the entire population of Qatar or Jamaica. Combined with rapid spawning is the way lionfish disperse their eggs and larvae. Unlike many native fish species, lionfish eggs are wrapped in a smooth, gelatinous membrane that is extremely light and can drift hundreds of kilometers while remaining viable. Lionfish larvae live freely in the water column for 25 to 30 days, more than enough time to ride the Gulf Stream from Florida to the Bahamas, Cuba, and Jamaica, then spread down to Central America, cross the Caribbean Sea, reach Bermuda, and even arrive in Brazil. In other words, if just one female spawns in Florida, her offspring can appear in 3 different countries. This is the core reason why every control effort fails. You can hunt an adult lionfish. You can catch 24,000 individuals in a single competition, but you cannot hunt millions of eggs floating in the open ocean, and you cannot set traps for 2-millimeter larvae drifting with the currents. But here's the thing. In their native Pacific home, lionfish have never been a disaster. They are simply a normal part of coral reef ecosystems and do not cause ecological collapse. The reason is very simple. Nature there has had millions of years to prepare. Pacific sharks know exactly how to attack lionfish from below, where there are no venomous spines. Giant groupers weighing up to 300 kilograms are large enough to swallow lionfish whole without any harm. Large octopuses use their tentacles to pin the fins, neutralize the venomous spines, and then strike from behind. Even moray eels, snappers, and reef sharks have learned to recognize the scent, shape, and body language of lionfish. All of these species evolved together, which means the Pacific ecosystem has a full control force in place, keeping lionfish from ever exceeding 0.5 to 1% of total reef biomass. In the Caribbean, however, everything is completely reversed. Without natural predators, all limits are removed. Small Caribbean fish do not even know to avoid lionfish. The National Oceanic and Atmospheric Administration once recorded footage of a school of damselfish casually swimming around a lionfish, mistaking it for a harmless species, only to be wiped out within seconds, sucked in like debris by an underwater vacuum cleaner. This phenomenon is known as naive prey syndrome. But wait, the Caribbean still has sharks, the apex predators at the top of the food chain. In theory, they should have been the saviors of this ecosystem, but reality is far harsher than you might expect. In nature, sharks can eat lionfish, but they almost never do so intentionally. Not because sharks are weak, but because they never evolved to deal with a fish armed with 18 venomous spines carrying neurotoxins. In their Pacific homeland, predators had millions of years to learn how to handle lionfish. In the Caribbean, native reef sharks are essentially information blind. The National Oceanic and Atmospheric Administration recorded a shocking statistic. Across more than 10,000 hours of observation of Caribbean reef sharks, there were only 2 instances where sharks bit a lionfish, and in both cases, they immediately spit it out. To a shark, a lionfish is like a strange meal with sharp spines, an unfamiliar smell, high risk, and low reward. As a result, during the early years of the lionfish invasion, there was almost no evidence that Caribbean sharks hunted them on their own. The rare cases where sharks did eat lionfish usually happened by accident, when they stole lionfish from fishermen's lines. Then researchers in the Bahamas and Florida decided to try an unprecedented strategy, training sharks to eat lionfish, much like teaching a lion to distinguish between edible prey and poisonous meat. The method was direct and risky. Divers killed lionfish underwater and repeatedly fed the carcasses to sharks hundreds of times over. What happened next stunned the ecological community. After a few years, many divers began reporting rare sightings, Caribbean reef sharks and nurse sharks charging into reefs and attacking live lionfish without any bait. Several videos spread across YouTube showing sharks chasing lionfish as if they had hunted them their entire lives. A scene no one would have believed just 10 years earlier. However, this adaptation occurred only in areas with frequent divers, places where sharks were unintentionally trained through tourism. In remote waters with no diver presence, sharks still ignore lionfish just as before. This means it is not a miracle solution capable of saving the entire Caribbean, but it remains the only long-term glimmer of hope that nature itself may be able to create. Even though sharks offer a small and fragile glimmer of hope, scientists still face a hard reality. Sharks cannot be everywhere, and they cannot rescue the ocean fast enough. So the real question becomes, can nature itself slowly find a way to rebalance the chaos caused by lionfish? The first optimistic sign comes from groupers, one of the largest predators on Caribbean coral reefs. During the early years of the invasion, the National Oceanic and Atmospheric Administration identified groupers as potential natural enemies, but there was no evidence that they actually ate lionfish. For a long time, everyone assumed groupers were simply powerless against this invader. That belief changed with a 2012 study by Oregon State University. In the Bahamas, where conservation laws banned grouper fishing and populations recovered strongly, researchers began observing giant groupers more than 1 meter long, actively biting and swallowing live lionfish. The frequency was still very low, only about 1 to 2% of observations, but it marked the first clear sign that nature was beginning to self-correct. The second hopeful signal comes from trumpetfish, a long, slender ambush predator, often compared to a living flute. A 2021 study by the Smithsonian Marine Station found that trumpetfish had begun ambushing juvenile lionfish on reefs with high native species density. This behavior had never been recorded before. Trumpetfish normally hunt small reef fish hiding in coral, but they had shifted strategy to target the lionfish's most vulnerable stage, just after hatching, before their venomous spines are fully developed. The third, and perhaps most important positive sign comes from the structure of the ecosystem itself. A 2019 study by the Coral Reef Alliance showed that coral reefs with high biodiversity, meaning many small fish species, multiple layers of marine vegetation, and abundant rocky hiding spaces, were damaged 40 to 60% more slowly by lionfish than simple, uniform reefs. The reason is straightforward. Biodiversity creates a natural shield. More algae-eating fish means less algae smothering corals. More competing species makes hunting harder for lionfish. More crevices allow small fish to hide more effectively. You can think of a coral reef like a neighborhood. One with many escape routes survives disasters better, while a neighborhood with only one road collapses quickly. Coral reefs follow the same rule. The richer they are, the more resilient they become. But remember, all of these signals are still small, scattered, and extremely fragile. Nature is trying to correct the damage, but this process moves far more slowly than the destruction caused by an invasive species that can double its population in a matter of months and spread hundreds of kilometers in a single breeding season. Finally, when we look back at this entire disaster, we have to accept a simple but bitter truth. Lionfish are not at fault. They are only doing exactly what nature programmed them to do: hunt anything they see, reproduce as fast as possible, and occupy the empty spaces left by native ecosystems. The real disaster began the moment humans accidentally opened the door and allowed them to enter an ocean that had never evolved predators specifically adapted to stop them. And once an invasive species establishes itself in the ocean, forcing it out becomes almost an impossible mission. So the question now falls to you, the person watching this video. Can we truly contain lionfish over the next 10 to 20 years? Can the Caribbean ecosystem, once one of the richest seas on the planet, fully recover? Or are we witnessing the birth of a new ocean, with fewer fish, less coral, and more invasive species? If you want me to continue with the next video, can lionfish spread to the Mediterranean? Leave a comment with the word lion below. And do not forget to subscribe